Number 9 says the ratio of the spheres is 3 to 4. The surface area of the smaller sphere is 27 meters squared. They want you to find the surface area of the larger sphere. So if we have similar figures here in this situation, spheres are all circular. They should be similar in nature. They're giving us the ratio of the spheres. Now we can assume this 3 to 4 ratio is in the first dimension. We're talking about the radii, or each radius has that particular ratio. So we could say, for instance, in this problem, this is 3 and this is a length of 4. Okay, great. Now we have the surface area of the smaller sphere is 27 meters. We want the one of the larger. And we can actually just apply what we know about similarity, and we're talking surface area here. So that's what, second dimension? Yeah. So we could say surface area, I'll just put S for smaller. And we just square what's in the first dimension, right? So in essence, for A, I would be putting 3, and for B, I would be putting 4. And then this surface area right here, that's our 27. We would substitute that right here in the surface area of our smaller sphere. So really what we're doing is we're just finding that fourth and final piece that's unknown. So I need to make sure to fill this in appropriately. I would put 27 here. We'll just put X for unknown. We're going to square A. Fourth power there. My bad. I get ahead of myself sometimes. And then we have 4 squared on the bottom. Let's clean it up a bit. Let's say 27 over X equals 9 over 16. And then we can cross multiply. There's that cross multiplication again. And then 27 times 16. Let's see what that gives us here. 27 times 16 in the calculator gives us 432. Let's make a little bit of room here. Divide by 9, divide by 9. What do we get? I hope it's a nice clean number. Yes, it's 48. And do we have units? Yes, we do. Meters squared. Okay, so it's supposed to be easier. I suppose you could go through, you only need to know radius to find surface area. I think surface area is like 4 pi r squared. You know, you could actually do the gymnastics and compare the two surface areas that way using the complete formula. But the idea is to actually use this particular formula here. For volume, we would just do we would just take the volume of our smaller sphere compared to the volume of our larger sphere, and then look at the ratios of their radii, respectively, A and B, but we have to cube it instead of squaring. So there you have it. Thanks for joining me on this video, and see you in the next video.